Hi everyone, thanks for watching. In this video, we're going to explore the meaning of the word isotope and what it has to do with the subatomic particles inside of an atom. Let's start off with a quick review of atomic structure and some things you should probably already know about atoms. First of all, in the middle of an atom is a nucleus containing protons and neutrons. Protons and neutrons, by the way, have equal masses at what we call 1 atomic mass unit, or 1 AMU. Surrounding the nucleus are electrons. In energy levels or rings, the electrons are so insanely small they pretty much have no mass at all. So we say an electron has 0 AMUs. Those masses are going to be important for something we talk about later in the video. The big question to consider first today is, why is this atom an atom of carbon and not a different element? Why isn't it nitrogen or lead or gold? Is it the 6 protons, the neutrons, the 6 electrons? Is it the 2 electron rings or something different altogether? The answer to that question is it's actually the 6 protons that makes this atom an element of carbon. That means any atom with 6 protons, regardless of how many neutrons or electrons, will still be carbon. We could put in an extra neutron, even 2 extra neutrons. As long as it still has 6 protons, it's still carbon. We could even put in extra electrons, as many as you want, really. This is still carbon because it has 6 protons. And it's actually our first key idea for the video. It's the number of protons that determines the type of element an atom will be. No other subatomic particle affects this at all. Once you understand that, we can actually take a look at isotopes and what that word means. We'll introduce this by modeling 3 different carbon atoms using the same conventional symbols we looked at in the first example. I'm going to fill those in on these 3 different atom outlines. Since they're all going to be carbon, they all have to have 6 protons. That's it. Since the protons is the only thing that makes them carbon, we can start there. To make them different carbon atoms, however, I'm going to change the number of neutrons, 6, 7, and 8. And by doing that one simple thing, we've actually already created 3 different isotopes of the element carbon. The one on the left will be the lightest isotope at a mass of 6 plus 6, 12. The one in the middle, a little bit heavier, on the far right would be the heaviest isotope at 14, 6 plus 8, 14. We could keep going, by the way, and add in 9, 10, or 11 neutrons for some super heavy isotopes. We could even go the other direction and take away neutrons, 5, 4, or 3, and make some super light isotopes. As long as you're changing the mass, you're creating different isotopes of that element. Let's go back at this point to my original 3 at 6, 7, and 8 neutrons. You might be wondering, what about the electrons? We've been ignoring them this whole time. So let's consider putting in 6 electrons to each of these atoms to start. To give them different numbers of electrons, I'll put in 2 more to make 8 electrons here, 9 here, and 10 here. Before you get too concerned, there's some good news, and that is that the electrons don't matter at all. The electrons do not affect an atom's isotope status because they don't change its mass. Remember, electrons are so small, they have pretty much no mass at all, 0 AMUs. So you can put in as many as you want, and it doesn't affect these atoms being isotopes of one another. At this point, we should be ready to define what an isotope actually is. Isotopes are atoms with the same number of protons, like these 3 all had 6 protons, but with different numbers of neutrons, keeping in mind that the electrons didn't matter or affect this at all. Another way to define this or think about an isotopes is that they are atoms of the same element. These all had 6 protons, which makes them all carbon, but what was different was the different masses, making our final key idea for this video the definition of isotopes. That concludes our video on isotopes. Thank you guys very much for watching. Here's a brief summary to review some of the key ideas we looked at.